Okay, everybody, let's see how this is going to work out for us. We're going to do section 12.1 today, trigonometric functions and right triangles. Everybody's familiar with a right triangle, I hope. It's got a 90-degree angle. No, it doesn't have to be pointing to the right. I made that mistake my first year teaching. All the kids thought that. So anyway, so when you have an angle, let's say this is our angle we're looking at. Okay, we'll call that theta. Okay, that's a theta right there. Okay, so if you're looking at this, the leg opposite this angle right there, see, opposite, across, adjacent, next to. You sit next to somebody, you're adjacent, and then the hypotenuse is always opposite the right angle. We're going to look at the 6 basic functions. That's sine, cosine, tangent, cosecant, secant, and cotangent. Okay, these 3 are all reciprocal functions. They're called reciprocal functions because the cosecant is 1 over the sine, the secant is 1 over the cosine, and the cotangent is 1 over the tangent. Okay, so what we're looking at here is for the sine of theta. So for the sine of this angle right here, it's going to be the side opposite over the hypotenuse. So that's going to be opposite over hypotenuse. Okay? And then that's considered the sine. It's the ratio of the opposite leg over the hypotenuse. All right? The cosine is going to be the side adjacent. My pens haven't worked in 3 days. Plus 10, 13, over the hypotenuse. Okay, let's find some pens that work here, people. And then the tangent of theta is going to be the ratio of the opposite side over the adjacent side. So that would be opposite, there we go, over adjacent. All right, and then the cosecant is just going to be the reciprocal of that. So that's going to be hypotenuse over opposite. This is going to be hypotenuse over adjacent. And then the cotangent is going to be the adjacent over the opposite. Okay, those are our 6 basic functions. All right, and again, these are called the reciprocal functions because they're the cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. Okay, so how I remember this, some people remember, well, I'll tell you that in a minute when we get there. All right, so let's take we're no breaking. You guys can stop and pause. You don't need me to break. Okay, so here we go. So let's draw us a little triangle here so we can see if we can practice these. Okay, nice little right triangle, maybe. And I can't see the screen on my phone right now, so I hope I'm actually recording this because it would really stink if I wasn't. But we shall see. All right, so let's just these numbers right now, we're just going to put in here. This would be a Pythagorean triple because it makes a right triangle. All right, here's our theta. And we are going to find the 6 functions. So we're going to find the sine of theta, the cosine of theta, the tangent of theta, and then we are going to find the cosecant, the secant, and the cotangent. So remember, all these are the ratios of the sides. So sine, remember, is opposite over hypotenuse. So here's theta. The side opposite would be 8. The hypotenuse, 17. Opposite over hypotenuse, 8/17. Cosine, theta is right here. So it's adjacent, 15 over hypotenuse, 17. And then tangent is opposite over adjacent. And then for these, all you have to do is take the reciprocal. So remember, the reciprocal is like putting 1 over it. Some of you might say flip it. It's not always just flip it, but 17 over 8, 17 over 15, and 15 over 8. Now, I know some of you might have done this before, maybe in geometry, and you learned a cute little, it's usually SOHCAHTOA. So the sine is the opposite over the hypotenuse. So that's our SOHCAHTOA, and then the cosine is the adjacent over the hypotenuse, and then the tangent is the opposite over the adjacent. SOHCAHTOA. Sounds like, no, we won't go there. But I had a weird, maybe he was a hippie back in the day, Algebra 2 teacher, and he taught us to remember this. Some old hippie caught another hippie tripping on acid. Yeah, I don't recommend that, but that might be a little cool way to, remember it. All right, so I think we're about a third of the way done. Let's move on. Flippy, flippy. I gotta get that out. Now, guys, this might be a little different than the notes that I have on Skyward. Not Skyward, dummy. eCampus, yeah, that's it. Because I didn't do them exactly the same, but that's okay. All right, so let's do another right triangle. All right, it doesn't matter how you draw it, as long as you got the right angle. I don't mean right by wrong. I mean, the 90-degree angle. Like I said, I like to make them different ways. So I never saw right. Yeah, it can be any way it wants to be. Okay, so we're just going to put some random values in here. It doesn't matter. This is A, B, C. Okay. I'm going to put some 5 and 8. Okay. Yes, I know I missed a side on purpose. This is going to be the angle we're going to be working with. That's angle C. So instead of theta, we're just going to use the vertex. All right. So I want to find the 6 trig functions of angle C. All right. So you notice we're missing a side. Hello. No go. So I know all of you know how to find that side because it's like probably one of the first things you learned. That was the old what? Wait for it. Pythagorean Theorem. So we're going to use a squared plus b squared equals c squared. And again, a is usually the side opposite the angle. So this is kind of a right here. Doesn't really matter as long as C, or the long side, is always opposite the right angle. It's not always C. So you can't go by that. All right, so we're going to have a squared plus 5 squared. I know that's not across from C, but the hypotenuse has always got to be the longest, which is the C here. So plus 5 squared equals 8 squared. Do some quick math. I know it's been a while. Subtract, and we get 39. Square root, a equals square root of 39. Now some of you are saying, oh, wait a minute, you got to do plus or minus. No, because a distance can't be negative. Come on now. You know that. All right, so let's find our 6 functions. So the sine of C, opposite, there's C, so opposite over hypotenuse, 5 over 8. Cosine of C, adjacent, so let's write that in. That's a square root of 39. So it's going to be adjacent, square root of 39 over hypotenuse 8. And the old tangent is going to be opposite over adjacent. So there's C, opposite over adjacent, 5 over radical 39. You know we can't leave the radical there. So multiply both top and bottom by that, and we get 5 radical 39 over 39. And we come over to cosecant. I know you think cosecant would go with cosine, but it doesn't. So no, I'm not messing up. Cosecant of C, again, just reciprocal of that, 8 over 5. The secant of C, 8 over square root of 39, which by now you know how that goes. And then the tangent, cotangent, dummy. Yeah, there's my first mistake. It took me a page and a half, that's not bad. Usually it's in the first 5 minutes. Cotangent, dummy, is, now remember, we're going to take the reciprocal of this, so the radical 39 is going to be on top. And there we go. Okay? So far, so good, I hope. All right, so moving on. These lovelies, I know you remember these guys. Your special right triangles from geometry. There was 2 of them. And I know in your head right now you're saying, yep, I remember them. There's the 30, 60, 90. Let's start with that guy. So we can draw him out. All right, got a right triangle, right angle. We got our 30 degrees. And we got our 60 degrees. And I don't know if you guys remember these, the relationships, but if we took our short leg, which would be the opposite 30, your shorter leg's always opposite that, and we call that x, the hypotenuse was always 2 times as big, and then the long leg, opposite the 60, was radical 3 times bigger than the short leg, okay? So if we do our functions for this, and these are always going to be true about every 30, 60, 90 triangle. It doesn't matter the length of the sides. It doesn't matter. They're always going to be in this ratio right here, okay? So the sine of 30 degrees, no matter how big the triangle or how long the sides, the sine of 30 degrees, if we look, here's 30, opposite over hypotenuse, is x over 2x, which reduces to 1/2, okay? So every 30 degree angle is going to have a sine of 1/2. Every 30 degree angle, cosine of 30, here's 30, so adjacent, x radical 3 over 2x. Simplify that, the x's divide out, radical 3 over 2. And then the tangent of 30 is going to be 30, so opposite over adjacent. So x over x radical 3. The x's divide out, we get 1 over radical 3, which is radical 3. So I'm not going to do the reciprocal functions, okay? Because you can find those, but we need to squeeze in. My bad, I forgot. The sine of 60, the cosine of 60, and the tangent of 60. And you're gonna see a little relationship here. So here's 60, so sine is gonna be opposite over hypotenuse. So x radical 3 over 2x, which that reduces to radical 3 over 2. Cosine 60, so adjacent x over hypotenuse, 2x, which is 1/2. And then the tangent of 60, opposite over adjacent. Oh my gosh. I hope you guys saw that dumb mistake I made. But If you didn't, I'm going to fix it in a minute. So opposite x radical 3 over x, which is just radical 3. No, they're not the same because, hello, 1 over radical 3 would be actually what if I multiply both of my radical 3? It would be radical 3 over 3. Don't blame me. I've been out of practice for a while. All right, moving on. I know you're like, good gracious, is this thing ever going to end? You know I love to talk. And I'm trying to go a little bit slower because I'm not there to answer questions. But you guys know when I get my office hours, that's on eCampus. I think I sent it out too, but we've got to communicate. Once a week, every one of you need to make contact with me. I make contact with you, whether it's a message, an email, a text, doesn't matter. 45, 90, okay? Now, I know they don't look the same, but you know what? You don't go by looks. I've told you guys that a lot. All right, so again, if this is x, this has to be x. Then if we actually did the Pythagorean Theorem, x squared plus x squared is 2x squared. Square root of 2x squared is x radical 2. So we need to do the sine of 45, the cosine of 45, and the tangent of 45. We only have to do one set because 45 and 45, they're the same angle. So sine of 45, doesn't matter which one you pick. This one, opposite over hypotenuse, is x over x radical 2, which is 1 over radical 2, which is radical 2 over 2. And you're going to see the cosine, 45, adjacent over hypotenuse. Same exact thing, which comes out to be radical 2 over 2. Then the tangent, opposite over adjacent, or opposite over adjacent, x over x is 1. These are always going to be true. No matter how big or whatever the triangle is, they're always in these ratios. So the sine of 30 is always 1/2. The cosine of 30, always radical 3 over 2. The tangent of 30, always that. Sine of 60, always that. Cosine of 60, boom, and so on. And I know what you're thinking, and the answer is yes. You will have to remember those functions. All right, so since I've got all the time in the world, I wanted to do a few problems here. And you can stop, you can pause. Excuse me. I'm gonna try to keep going. I have no idea how long I've been going because I can't see my phone. And I'm hoping it's recording. It would really stink. I was gonna say suck, but I changed my mind. It would really stink if this wasn't recording right now. So I'm hoping, and you think I'm gonna get up and take a look, and I think I am gonna stand up and take a look here, but if I not bump the camera, it's very precarious. So, I'm a little out of whack. I hope you guys can still see it. Oh, crap. That's not good. And I mean papers down here. Oh, no. Well, we're gonna keep going. These are online. So if I was a little wacko, so sorry. There's only a little bit on each side there, so we will survive. Because, yeah, I'm not redoing these. No. Not gonna do it. These are already posted, I believe, on eCampus on calendar. All right, so I'm gonna give you X here, and I'm gonna give you 8 here, and I'm gonna give you this 30-degree angle right here. Okay, I'm telling you that's a 30-degree angle. So we wanna find the value of X. Okay, so I know the cosine of 30. Remember, cosine, caught another hippie, adjacent over hypotenuse equals x over 8. So if we're solving this equation, 8 times the cosine of 30 degrees equals x. Now, you can do this on your phone. Make sure you're in degrees. But all I'm going to do, and I don't know if you can see, I hope you can. So I got to do 8 times the cosine of 30. So I'm going to make sure I'm in degrees, and I'm not. On your phone, you turn it sideways. If you got an iPhone, you know you get your calculator. Okay, so I'm just literally going to do 8 times the cosine of 30 degrees. And I get 6.298. So now if I didn't have a calculator, so that's my calculator, not exact answer. I know the cosine of 30 because I just learned it is radical 3 over 2. 2 goes into 8 4 times, is actually 4 radical 3 is my exact answer. Calculator answer is approximately 6.93. Okay, let's try another one. 2 more to go and you're out of your misery. Until the next time. I think we're doing 3 video lessons this week. And yes, I'm drawing all the triangles the same. And then I'm going to have to watch this video, which is going to be fun. RST. Okay, we got 10. We got 6. We're going to do the same angle right here. Notice I'm not giving you the degree this time. So in relationship to angle T, we have to look and see what we have. We have, let's see, T, so this is the opposite. And this is the hypotenuse, opposite the right angle. So I need to think, what trig function uses opposite and hypotenuse? That's the sine. So the sine of T equals opposite over hypotenuse with 6 over 10. So here's where the calculator has to be used, okay? So if you know the value of the function, which we do, it's 6/10. So if you know the value of the function, okay, get out of here, bug. Then we need to use the inverse, okay? Sometimes it's called like the arctan or arc sine or something like that. On some calculators, it might be that. So it might be like arc sine, something like that. But anyway, so that's the little button on the calculator that is sine with a -1 on it. Okay, that doesn't mean reciprocal. So if I go back up here, so the 6/10 is the sine. I'm not looking for the sine, I'm looking for the angle. So I would do sine inverse of 6 divided by 10, and that's going to equal angle T. So calculator back again. I don't know how much of it you can see, but again, just text me, call me, whatever, during, and I'll help you out. So I'm gonna go second sine, and then I'm gonna go 6 divided by 10 equals, and that's about 36.9 degrees. So angle T, about 36.9 degrees. Okay? And let's do one more. Okay, and you're gonna see where you're gonna encounter these guys is in a lot of word problems. Okay, not a lot. Now, remember the practice I'm gonna give you here at the end, it's practice, okay? I would like you to do it and try it. I haven't got them all worked out yet. I will, eventually. So let's say blah, blah, blah. You're looking up at the top of who knows what. Let's say this is a cliff. You're up here on a little cliff, okay? And it's like, yay, I'm up here. You can't see me, but I can see you, and I'm spying on you because you're down here. Here's the beach. I don't know who you're spying on, but you're looking at somebody. And this person does look up and see you. You don't even know. See, they're laying down here. They may be dead, though, so I don't know how they would see you. I don't know. So they're 200 feet away. We want to know how high up you are. Okay? That was just a quick on the fly, make up a problem kind of thing. So, again, in relation to 76, we have opposite, we have adjacent. So that's tangent. So the tangent of 76 degrees equals opposite over 200. So 200 times tangent of 76 equals x. Again, back to the calculator. Now again, see, we don't know the function. We don't know the value of the tangent. So we don't use the inverse button. We're just gonna go tangent 76, make sure you close your parentheses, times 200. We're gonna get about 802. So that cliff is about 802 feet high. Don't jump. Okay, so there we go. I hope this worked out for you. You'll let me know, give me feedback. You know, I like constructive criticism. Haha. So practice in the book, 795, 96, 3 through 33, multiples of 3. So 3, 6, 9, you know, so I think that's like 12 problems to practice on. Okay, actually, and I did put the workbook pages, I scanned them, not workbook, my bad, textbook. I scanned them and they are on eCampus also. So I hope this turned out. We shall see. Bye-bye.